In this video, we will learn about potential energy, its classification. Through that, we will learn that there are two types of potential energy, and also we will learn the derivation of the mathematical expression for the two types of potential energy. So first, let us begin with the definition of potential energy. What potential energy ultimately mean? Potential energy is an energy or is the energy possessed by a body by virtue of its position. That means if an object is up above the surface of earth, it possesses gravitational potential energy because it is against the gravity of earth. If an object is on either sides of mean position, like a spring, due to its elasticity, when we stretch it on either sides, then amount of energy possessed by that spring is said to be the elastic potential energy. So now let's begin with the definition once again. So what is potential energy? It is the energy possessed by a body due to its position. We can classify potential energy as the gravitational potential energy and elastic potential energy. Observe in this case, there is an object of mass m at ground level. This object, some amount of force is applied on it. As a result, it is raised to a certain height h. Since a force is applied and the body is displaced, some amount of work is done. In this case, the amount of work done in raising this body above the surface of earth gets stored in this body in form of its gravitational potential energy. By work energy theorem, the amount of work done in raising the body above the ground level gets stored in the body in form of its gravitational potential energy. So, gravitational potential energy must be equal to the work done in raising the body through that height. Since we know that work done is a force into displacement, and here force is actually weight of the body, which is m into g, and displacement is a h. Hence, gravitational potential energy possessed by a body can be calculated using the formula mgh. M is mass of the body, g is acceleration due to gravity of that place or planet. In case of earth, gravitational acceleration due to gravity is taken as 9.8 meter per second square, or sometimes at 10 meter per second square, and h is the height through which the body is raised. Now in case of elastic potential energy, observe a body of mass m is suspended through a spring. Since no force is applied, there is no extension. So in the first case, let force be F1. But in second case, this spring is stretched in a downward direction with some force F2. As a result, an extension of X is seen. The amount of force applied is directly proportional to the amount of extension seen in the spring. We can write force as equal to some proportionality constant times the extension seen in the spring. Here K is the spring constant. Now in first case, force is Kx. Since no extension is seen due to no force applied, so in the first case force is 0. In the second case, since force is applied, some amount of extension, that is x amount of extension, is seen. Here the average force, that is F, is F1 plus F2 by 2. So average force is F1, which is 0. F2 is the Kx overall by 2. So it is Kx by 2. Now, what about the elastic potential energy? Elastic potential energy is the amount of work done in stretching this body below the mean position. So work done is a force into displacement. In this case, a displacement is x, and force is the average force, that is Kx by 2, and here extension is x. So elastic potential energy is calculated using the formula half times k. K is the spring constant, and then x into x is x square. Elastic potential energy is calculated using the formula half kx square. So in summary, the gravitational potential energy is calculated using the formula mgh, where m is mass of the body, g is acceleration due to gravity of that place or planet, and h is the height above the surface of that planet up to which the body of mass m is raised. And elastic potential energy is calculated using the formula half kx square, where k is the spring constant and x is the displacement seen in the spring due to the application of force. Hope this information is useful. If you like the video, consider subscribing to this channel. That will be a great motivation factor for preparing better videos.